Assalamu alaikum. In this video, we'll talk about logarithm and len function. In this video, we'll talk about converting between logarithm and exponent and using properties of logarithm to simplify it. Okay, so if you have an exponent function like a power x equal b, and you want to find the inverse of this exponent, actually the inverse of an exponent function is the logarithm function. Now, if you want to rewrite this exponent and convert it to the logarithm, you have to start with the logarithm notation and then put all the numbers a and x and b like this on the logarithm. So we will have logarithm for base a for b is equal x. Actually, the logarithm function is a function to find the exponent or the power. And if you have a logarithm function like this and you want to rewrite this logarithm or convert it to the exponent form, so we will convert it like this. So we will have c power y equal d. So this is how to convert between the logarithm and the. Now see this example here, write in logarithmic form. Now we have 5 power 3 equal 125, and I want to rewrite this exponent form to the logarithm form. So I will start with the logarithm notation and then I will put the number like this. So I will have logarithm for base 5 for 125 is equal 3. Same as if I have 10 power 2 equal 100. So I will write it in logarithm form like this. Put the logarithm notation and then move the number and put it like this. Now, since here the base is 10, so 10 always can be hidden in the logarithm. So it can be like this. So logarithm 100 equal 2. So if there is a logarithm without base, so mean that the base is 10. Okay, so another example, we have e power x, the exponential function, equal y. Now, I want to rewrite and convert this function to the logarithm form. So I will put the logarithm notation and I will put the numbers like this. So logarithm for base e for y equal x. Now, when we have in the base e, so mean that the logarithm, it can be written as len. So len is the logarithm for base e. Okay. See this example now. Write in exponent form. So we will convert now from logarithm to the exponent. So the first example, we have logarithm for base 4 for 1024 is equal 5. Now we want to rewrite this logarithm and convert it to the exponent form. So we have now 4 to the power of 5 is equal 1024. So this is how to convert from logarithm to exponent. Another example, we have logarithm for 1000 is equal 3. Now, since we have logarithm without base, as we mentioned, the base always is 10 like this. So now I want to rewrite it in the exponent form. So it will be 10 to the power of 3 is equal 1000. So this is how to rewrite this logarithm to the exponent. Now we have len now for y is equal x. How can I convert len to the exponent form? As we mentioned, the len is the logarithm for base e. So if you have len and you want to convert len to the exponent form, direct put e and put the answer as a power, which is equal what inside len, which is y. So this is how to convert the logarithm form to the exponent form. Okay, so the properties of the logarithmic function. What is the properties of logarithmic function? Now, all of us remember the properties of the exponent function. In the product, we add the power. In the divide, we subtract the power. And when we have interior and exterior power, we will multiply. And any number except 0, power 0 is equal 1. And any number power 1, it's the same number. So, if we compare between this number and the property of the logarithmic, actually it's the same, because here, look here, for the first one, the product of any two numbers, okay, any two similar number, okay, we will add the power. It's like when we have logarithm for product, okay, this logarithm, it can be written as a sum of two logarithm. Okay, it's same as for divide. So because in the division, we subtract the power. So logarithm of division, it's actually the difference between two logarithm. And if you have interior and exterior power, we will multiply. So here, if you have a power inside the logarithm, actually you can multiply the power with the logarithm. Now here a power 0 equal 1, so logarithm of 1 is equal 0, and a power 1 is a, so logarithm a base a for a is equal 1. So this is the properties of the logarithm, and we compare it with the properties of the exponent. Okay, see this example, expand the logarithmic expression. So we have this logarithm and we want to expand this logarithmic and rewrite it as sum and subtract. So here we will start from these two numbers. Since this is x power 3 times y power 5, it's a product of two numbers inside logarithm. So based on this rule, so when we have multiplication, we can change the multiplication to add to logarithm. So we will put logarithm of x power 3 plus logarithm for y power 5, both are base 2. Now down here we have z, so it's divide by z. So since the division, or what is the after, or what's down, or the bottom number here, we will put it after the minus. So since z is the denominator, we will put it after subtract. So it's minus logarithm base 2 for z. Now we have two power here, 3 and 5. Now based on this rule that if we have a power inside logarithm, we can multiply the power with the logarithm. So I will multiply both powers with the logarithm. So I will have as a final answer 3 logarithm base 2 for x plus 5 times logarithm base 2 for y minus logarithm base 2 for z. Okay, see this example now? Write in single logarithm. Now we will have add and subtract logarithm, and we will change it to and rewrite it in single logarithm. Now we have this example. We have 3 ln x plus 2 ln y minus 6 ln z. Now we want to rewrite these 3 lens in single len or single logarithm. All right. So actually we have here a number multiply with the len. This is the power of the number. So step number 1, any number beside the len or the logarithm, you have to put it as a power like this. So we have now len x3 plus len y minus len z. Okay, now since you have a plus and minus, so mean that in the single logarithm or single len, you will divide. So it's equal len and put the fraction. Now the number we added, we will multiply together, x power 3 and y power 2. And since len z is after subtract, so z, it will be the denominator. So the answer will be like this. So we have len x power 3 times y power 2 divides z power 6. Okay, so this is now the graph of logarithm, the function y equal logarithm for base a for x. Now, see in this graph, number 1, this graph covers this side from x axis, and the 0, it's not inclusive. So here we can find that the domain of this function is all numbers bigger than 0. So x is always bigger than 0, and we cannot substitute 0 or negative number inside the logarithm. Now it's cover all the numbers in the y axis, so mean that the range is all real number. And here, look to this part down. The graph of the function is very close to this part, so mean that we have vertical asymptote. And this vertical asymptote is the y-axis, which has an equation x equals 0. Okay, and here we have this point. This point is the intersection between the graph and the x-axis, so mean that we have x-intercept, which is the point 1 and 0. Okay, so video we talk about the properties of the logarithm, and we talk about how to convert between the logarithm and the exponent. This is about the logarithm expression. Thank you for watching us. See you next video inshallah.